Now I want to look at another way of estimating the area under a curve. Let's estimate the area under the graph of f of x equals the square root of x from x equals 0 to x equals 4, and we're going to use 4 rectangles. So here's a graph. This is just the square root function, and we want to do find the area from 0 to 4. So here's 4. So if I draw this line up here, we are looking for this area all in here. Okay, so first let's do this by using left endpoints. So here is my graph, and if I'm going to use left endpoints, I'm going to make rectangles such that the left end of the rectangle touches the function. So from 0 to 1, I am not going to have any rectangle at all because the left end of the rectangle would be at the origin. There wouldn't be any rectangle. So my first rectangle is this one. That's the one from 1 to 2. And so to find the area of this rectangle right here, I have a base that's 1. So this is going to be left, and we're using 4 rectangles. Well, I'm actually using 3, but the first one isn't here. Okay, so L4, I have a base of 1, and I have a height that's equal to the value of the function at 1. And the function is the square root of x, so that's going to be 1 times the square root of 1. My next rectangle would look like this, and that's also going to have a base of 1, and the height is going to be the value of the function at 2, which is the square root of 2. And then my third rectangle, that also is going to have a base of 1, and it's going to have a height equal to the value of the function at 3, so that's the square root of 3. And if you do this out on a calculator, you get 4.146. And so that is my estimate using left endpoints. Okay, so now let's try using right endpoints. So again, here's my graph. And now I'm going to look at 4 rectangles where the height of the rectangle is determined by the right end of the rectangle where that hits the function. So here is my first rectangle, and so that one has a base of 1. So this now is R4, and that has a base of 1 and a height determined by the value of the function at 1. So that's going to be the square root of 1. Okay, and then my next rectangle looks like this. That also has a base of 1, and the height is determined by the value of the function at 2. So that's going to be the square root of 2. Okay, and now my third rectangle looks like this, and that's going to have a base of 1, and it's going to have a height that's equal to the value of the function at 3. So that's the square root of 3. And then my last rectangle looks like this. That's going to have a base of 1 and a height determined by the value of the function at 4, and that's going to be the square root of 4. And so if you type all this in on a calculator, you get 6.146. So now I have an estimate using left endpoints and an estimate using right endpoints. And so in this case, that's going to give me the range of the possible values. I had 4.146 and I have 6.146. But what if I want a better estimate, something that's closer to the true value, which is somewhere in between those numbers? Well, to get a better estimate, I'm going to use midpoints. So here's how that works. Here's the graph of my function, and my first rectangle is going to look like this, and the height of the rectangle is determined by where the middle of the rectangle hits the function. So that's going to be right here. So in this case, this is M4. That's what you use for midpoints. So we have M4, and I have a base of 1, and the height is determined by the value of the function at 0.5, because that's halfway, it's like right in the middle of that rectangle there, 0.5. So that's going to be the square root of 0.5. My next rectangle, that's going to look like this. That's going to have a base of 1. They're all going to have a base of 1. And now the height of the rectangle is determined by the value of the function at 1.5. So that's going to be the square root of 1.5. Okay, next I have this rectangle. So that's going to also have a base of 1. And the height of this rectangle is determined by the value of the function at 2.5. See right there. So that's going to be the square root of 2.5. And then my last rectangle, that's going to be this one right here. That's going to also have a base of 1, and the height of the rectangle is determined by the value of the function at 3.5. So that's right there. So that's going to be the square root of 3.5. All right. And so if you type this into a calculator, you end up getting 5.384. Okay, so let's actually look at comparing all these estimates and see how close they are to the actual area. Okay, so we were trying to estimate the area under the graph of f of x, which is the square root of x, from x equals 0 to x equals 4 using 4 rectangles, and here's the graph. And using left endpoints, I got a value of 4.146, and that was an underestimate. Using right endpoints, I got a value of 6.146, and that was an overestimate. Using midpoints, I got 5.384, and it's unclear if that was an overestimate or an underestimate. Well, the actual area is 5.333, so you can see that the midpoint actually got the closest to the actual area. So then you might wonder, why would you ever want to use an approximation with left endpoints and right endpoints? Well, remember, left endpoints and right endpoints did give us a range of values, so we kind of knew that the actual area had to be contained within that range. And in this case, that might be something maybe that's useful that you would want to know. Maybe you'd want a range. And then you could also go ahead and calculate the area estimate using midpoints, and that would give you a value that's in the range and maybe is closer to the actual area. So all of them have value. It just depends on the particular problem that you're trying to solve.